Finite math. In this video, we're going to review algebra by solving algebra equations. As you go through the video, you're going to see some icons on the left. This icon talks about the process, the steps that we're going to use to solve an equation. This icon has a couple examples for you, and then of course you have to practice. And then finally a self-quiz, just to see how you're doing. And of course, if you don't practice, you're not going to get good at it. So there's a video task at the end. And by the way, it's not magic, it's math. Let's get started. So what's the process? Well, the first step we want to do is simplify both sides of the equal sign. That means we're going to use the distributive property and collect like terms. The second step is to move the variable term to one side of the equation and everything else on the other side. And how we do that is by adding and subtracting. Step 3 is to isolate the variable by multiplying or dividing. What am I talking about when I say isolate the variable? That means I want to get x equal to a number or z equal to a number. I don't want 2x or 5x. No, I want x by itself. And then finally, we have to check to make sure we're right. Now there is one super important thing that we have to remember when we're doing algebra, and that's balance. Whatever you do to one side of the equal sign, you have to do to the other side of the equal sign. Super, super important. Balance, balance, balance. All right, let's look at one. 4x plus 6 equals 26. Now remember, we eventually want to get x by itself. So now I'm looking at the left side of the equal sign. I have 4x plus 6. Well, for step 1, there aren't like terms and I don't have the distributive property, so there's nothing to do over there. Equals 26. Well, once again, step 1, there's nothing to do. The second step tells us to get 4x by itself and everything else on the other side. That means I don't want plus 6 over there. Well, then we ask ourselves, what's the opposite of adding 6? That's subtracting 6. And that's what we're going to do, keeping balance to both sides of the equal sign. So let's see what we have. When we add straight down, we have 4x plus 0 equals 20. 4x plus 0 is just 4x. Now, I have the 4x by itself, but I need to isolate the x. That means I want x to equal something. Anytime we have a number next to a letter, it means to multiply. What's the opposite of multiplying? Yeah, dividing. I'm going to divide by 4 on both sides of the equal sign. Balance, 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 remember? So that gives me x equals 5. We think x equals 5, we really need to check it. So what I do is I rewrite the original equation, then I put 5 in for my x, and I follow orders of operations. Orders of operations say I have to multiply first. So 4 times 5 is 20, 20 plus 6 is 26, and 26 will always equal 26, so that means x equals 5, and we did it. Let's look at this equation. 21 equals negative 3x minus 6. Step 1 says, can we simplify anything? Well, if I look on the left side of the equal sign, it's just a 21. There's nothing to do. On the right side of the equal sign, I have negative 3x minus 6. Those aren't like terms, so I can't put them together. So the next step is we want to get negative 3x by itself. Now, it really doesn't matter what side the variable is on, okay? I want negative 3x by itself. I don't want the minus 6. The opposite of subtracting 6 or minus 6 is adding 6. So I'm going to add 6 to both sides. 21 plus 6 is 27. Negative 3x is just negative 3x. And negative 6 plus 6 is 0. Now I'm going to mention here that this is the last time that I'm going to be putting a 0 when we add numbers straight down and we get a 0. Okay? I just wanted to put it in for the first two just so everyone sees what we're doing. Because negative 3x plus 0 is just negative 3x. Now a number next to a letter means to multiply, and the opposite of multiplying is dividing, so we're going to divide by negative 3. The important thing to remember is that we always divide by whatever is hooked to the variable, and in this case it's negative 3. 27 divided by negative 3 is negative 9. We think negative 9 is x, but remember, we really need to check it. So I just rewrite my equation. I'm going to put negative 9 in for x. Orders of operations, negative 3 times negative 9 is 27. 27 minus 6 is 21. And yes, 21 equals 21. So negative 9 equals x. Awesome. Let's look at another one. 7x minus 14 equals 5x. Step 1, can I collect like terms on the left side of the equal sign? Nope, 7x minus 14 are not like terms. And then I just have 5x on the right side of the equal sign. Now what we want to do is we want to get all the x's on one side and everything else on the other side. Let's look at the left side for a second. I have 7x minus 14. 7x is not by itself, is it? But if I look at the right side of the equal sign, 5x is by itself already. So what we're going to do is we're actually going to subtract 7x from both sides of the equal sign. Because let me show you what happens. We end up with negative 14 equals negative 2x. Now the x is by itself on one side of the equal sign. That's what we want. I need to divide by negative 2, and we end up with 7 equals x. But let's check it. I was a little excited for the checking there. So we're going to rewrite our equation. Now we have to put 7 in for each variable. 7 times 7 is 49, so we're going to have 49 minus 14 on the left side, and 5 times 7 is 35. Well, 49 minus 14 is 35. Yay, we did it. 7 equals x. You're going to try these three by yourself. So the idea is you're going to pause the video, do these three by yourself, and then we are going to work them together. So pause the video, do them, and check them. All right, let's see how you did. The first one says 37 equals negative 8x minus 3. When I look at the left side of the equal sign, it's just 37. I can't collect like terms or anything like that. On the right side of the equal sign, I have negative 8x minus 3. Well, those aren't like terms, so I can't do anything for step 1. Step 2 says get negative 8x by itself. So I need to get rid of the negative 3 or the subtract 3. What's the opposite of subtracting 3? Adding 3. So that's what we're going to do. 37 plus 3 is 40 equals negative 8x. Now remember, negative 3 plus 3 is 0, but we're not going to be writing the 0 anymore. Next, I have negative 8x. Well, we don't want that. We just want x. We want x to equal something. So anytime we have a number next to a variable, it means to multiply. And the opposite of multiplying is dividing. Yep. And we divide by whatever is hooked to the variable. In this case, it's negative 8. I'm going to divide by negative 8 on both sides of the equal sign, and I end up with negative 5. But let's check it. I rewrite my equation. Then I put negative 5 in for my variable. Negative 8 times negative 5 is 40. 40 minus 3 is 27. Woohoo! We did it. X equals negative 5. Let's look at the next one. 11x minus 14 equals 4x. On the left side of the equal sign, they aren't like terms, so I cannot put them together. On the right side, we just have 4x. Now what we want to do next is we want to get all of the x's on the same side. On the left side, 11x isn't by itself, is it? But on the right side, 4x is by itself. So what we're going to do is we're going to subtract 11x from both sides. This gives us negative 14 equals negative 7x. Now we have the x's by itself on one side. But we still have a problem. We don't want negative 7x, we want x. So whenever I have a number next to a letter, it means to multiply. And the opposite of multiplying is dividing. So we're going to divide by negative 7. And we get 2. But let's check it. So I'm going to rewrite my original equation. Now remember to put 2 in for all of your variables, for all of the x's. 11 times 2 is 22. 22 minus 14 is 8. Woohoo! We did it again. Let's look at the last one. 5z plus 6 equals negative 29. On the left side, 5z plus 6, they're not like terms, so I can't do anything. On the right side of the equal sign, we have negative 29, there's nothing to do. I need to get 5z by itself. The opposite of plus 6, or adding 6, is subtracting 6, or negative 6. So that's what we're going to do to both sides of the equal sign. This gives us 5z equals negative 35. We want z by itself, so the opposite of multiplying is dividing, and yeah, we're going to divide by 5 on both sides. That gives us z equals negative 7, we think. Let's check it just to make sure. I rewrite my original equation. I'm going to put negative 7 in for z. 5 times negative 7 is negative 35. Negative 35 plus 6 is, yep, negative 29. So we did that one correctly too. For the last couple examples, we haven't talked about the distributive property. Let's look at the distributive property. So step 1, remember, is simplify both sides of the equal sign, either using the distributive property or collecting like terms or both. So I have 5 times b minus 3 equals 20. This is the distributive property. And what does that mean? I'm going to take 5 times everything in the parentheses. So 5 times b is 5b. 5 times negative 3 is negative 15. And then we just have equals 20 on the other side. From here, it's exactly like the ones we've been doing. 5b minus 15, they're not like terms, so I cannot collect them. 20 is just by itself. So we're on to step 2. We need to get 5b by itself. That means we need to get rid of the subtract 15 or negative 15. The opposite of subtracting is adding. Remember to do both sides of the equal sign. So we end up with 5b equals 35. Step 3, we need b by itself. We want b to equal something. So the opposite of multiplying is dividing, and b equals 7. We think, right? We always have to check it. So I write the original equation. And now you're going to notice that I put a parentheses for my variable because my 7 goes in for b. Orders of operations, so you have to do what's in parentheses first. 7 minus 3 is 4, and 5 times 4 is 20. Woohoo! We did it. Cool. Let's look at this one. 2 times x minus 5 equals 3 times x plus 2. It doesn't matter how many times we have the distributive property, we're going to do the same thing. I'm going to take 2 times x, which is 2x. 2 times negative 5 is negative 10. And we're going to do it on the right side of the equal sign also. 3 times x is 3x, and 3 times 2 is 6. This gives us 2x minus 10 equals 3x plus 6. For the last couple we've been doing, we've always had the x on one side, or it was easy to figure out where to put the x. We have an x on both sides of the equal sign, don't we? Well, traditionally, we like to put the x's on the left side, or the variables on the left side. Honestly, it totally doesn't matter. It's totally legal to put the variables on the right side. I like to put it on the left side. I also like to move the variables first. So that means I need to get rid of the positive 3x. The opposite of a positive 3x is a negative 3x. So I'm going to subtract 3x from both sides. This gives us negative 1x, or negative x, minus 10 equals 6. Woohoo, we did it! But we have negative x minus 10. We don't want the minus 10 there, do we? So the opposite of subtracting is adding. So I'm going to add 10. We end up with negative x equals 16. Does it matter if you write negative 1x or negative x? Nope, it doesn't matter. Both are totally legal. In algebra, we like to simplify things, so instead of writing the 1, we just write negative x. The problem is we want x by itself. We don't want negative x. So what we're going to do is we're going to divide by negative 1 on both sides. Well, why are we dividing by negative 1? Because a negative divided by a negative turns out to be a positive. And that's what we want. We want a positive x. 16 divided by negative 1 is negative 16. Let's check it. So I rewrite the original equation. And now I'm going to put negative 16 in for all of my x's. Orders of operations, say I have to do what's in parentheses first. So negative 16 minus 5, negative 16 plus 2. We end up with 2 times negative 21 equals 3 times negative 14. Woohoo, we did it again. Negative 42 equals negative 42. So yes, x equals negative 16 is our answer. Good job. Here are 3 for you to solve. You're going to pause the video, do these, and then we're going to work them together. Even though it doesn't say check on the bottom, you still need to check it. All right, pause the video and get started. Okay, let's see how you did. For the first one, we have 27 equals 9 times x minus 1. On the left side, it's just 27. We don't have anything to do. But on the right side, hopefully you notice we have the distributive property. So we're going to have 27 equals 9 times x, which is 9x. 9 times negative 1 is negative 9. Now, we have the 9x by itself on one side, but we need to get rid of the subtract 9. So the opposite of subtracting 9, or negative 9, is adding 9. So we're going to add 9 to both sides of the equal sign. 9x equals 36. We want x by itself. We're going to divide by whatever's hooked to the variable, which happens to be 9. And we have x equals 4. I'm guessing you're getting pretty good at this. Let's check it. What I'm going to do is I rewrite the original equation. I'm going to put 4 in for x. Orders of operations, say I have to do what's in parentheses first. 4 minus 1 is 3. 9 times 3 is 27. We did it. Let's look at negative q plus 7 equals 5. For this one, there's two ways we can think about it. The negative sign, we could say the opposite of q plus 7, which would be negative q minus 7. Or, thinking about using the distributive property, I could take negative 1 times q, which is negative q, and negative 1 times 7, which is negative 7, equals 5. Well, when I look at this, I cannot collect like terms on either side of the equal sign. Negative q minus 7. Well, I want negative q by itself. So the opposite of subtract 7 or negative 7 is adding 7. So let's do that next. Negative q equals 12. Well, we want q. We don't want negative q. So we're going to divide by negative 1 on both sides. So q equals negative 12. We think. We got to check it. So I rewrite my original equation. I put negative 12 in for q. Negative 12 plus 7 is negative 5. So the opposite of negative 5, or a negative times a negative, well, that gives us a positive. So we did it right. Awesome. Let's look at the last one. 7 minus 3 times x minus 8 minus 3 equals x minus 4. Hopefully this one didn't confuse you too much. The 7 we can't do anything with, but we do have the negative 3 times the x minus 8, so that is our distributive property. So we're going to take negative 3 times x, which is negative 3x, and negative 3 times negative 8, which is 24. Now the rest of it is just the rest of it. We're not doing anything. The next step is to collect like terms. Now I like to put like terms next to each other just so I don't miss anything. So we're going to have negative 3x, there's no other x's on the left side, plus 7 plus 24 minus 3 equals x minus 4. We're going to continue to look at the left side of the equal sign. We have negative 3x, but now all of my like terms are together, so it's super easy to do 7 plus 24 minus 3, which is 28. And that equals x minus 4. Do you have to put like terms together? No, you don't. And some of you might just circle the like terms and add and subtract them. Totally up to you. But as you watch through my next videos, you're going to see that I really do like putting like terms next to each other. Now we have negative 3x plus 28 equals x minus 4. We need all the x's on the same side and everything else on the other side. Traditionally, we like to put the x's on the left side. I like to do that. Do you have to do that? No, totally up to you. And I also like to move the x's first. So the x on the right side of the equal sign, I don't want. So I'm going to subtract x from both sides. This gives me negative 4x plus 28 equals negative 4. Cool, I have an x by itself on one side, but I have the plus 28. I need to get rid of the plus 28, or adding 28. So we're just going to subtract it. This gives us negative 4x equals negative 32. Once again, I want x by itself. I want x to equal something. I don't want negative 4x. So I'm going to divide by negative 4 on both sides. So x is 8. But let's check it. So I write my original equation. Now I'm going to put 8 in for all of my variables, all of my x's. Orders of operations say I have to do what's in parentheses first. So I'm going to do 8 minus 8, which is 0. 3 times 0 is 0, so we have 7 minus 3, which is 4, and 4 equals 4, so yep, we did that correctly. Cool. Now here's the self-quiz for this video. You're going to pause the video, complete the questions, then press play to check your answers. Now the whole point of the self-quiz is to do these problems without looking back at your notes. Whenever you have to look back at your notes, that is what you have to practice. And as we check the solutions together, whatever you get incorrect, that's also what you need to practice. All right, pause it, and then do it, and then press play, and we'll work it together. All right, let's see the first one. So the first one is negative 6x plus 6 equals negative 2 times 2x plus 8. Well, this one we have the distributive property on both sides of the equal sign, so we need to do that first. A negative times 6x, or negative 1 times 6x, is negative 6x. Negative 1 times 6 is negative 6. Then we have negative 2 times 2 is negative 4x, and negative 2 times 8 is negative 16. Now we need to get all the x's on one side. I like to put them on the left side, so let's do that. I have negative 4x on the right side. I don't want it there. The opposite of subtracting is adding. So we're going to add 4x to both sides. We end up with negative 2x minus 6 equals negative 16. I want negative 2x by itself, so I'm going to add 6 to both sides. We end up with negative 2x equals 10. I want x, not negative 2x. So I divide by whatever's hooked to the variable, which happens to be negative 2, and we end up with 5, because a negative divided by a negative is a positive. Let's check it. I'm going to put 5 in for all of my variables. Orders of operations say I have to do what's in parentheses first. So 6 times 5 is 30. 2 times 5 is 10. Well, 30 plus 6 is 36. 10 plus 8 is 18. Negative 36 is negative 36. And negative 2 times 18 is negative 36. Woohoo! We did it. Awesome. Let's look at the next one. 4 equals 4 times x minus 8. On the left side of the equal sign, there's nothing to do. But on the right side, we have the distributive property. So we're going to take 4 times x, which is 4x. 4 times negative 8, which is negative 32. We notice that 4x is by itself on one side of the equal sign. But we need to get rid of the subtract 32 or negative 32. So we're going to add 32 to both sides. We have 4x equals 36. We want x. The opposite of multiplying is dividing, where you divide by whatever's hooked to the variable. So we end up with x equals 9. But we got to check it. This means we rewrite the original equation. We put 9 in for my variable. 9 minus 8 is 1. 4 times 1 is 4. Yeah! Awesome. Let's look at the last one. 5 times 3q minus 4 equals 8q plus 15. On the left side, we have the distributive property, so let's do that first. 5 times 3q is 15q. 5 times negative 4 is negative 20. On the right side, we just leave it alone. There's nothing to do. When I look at the left side, I cannot collect like terms. On the right side of the equal sign, I cannot collect like terms either. So what we want to do is we want to get the variable or q on one side. I like to put my variables on the left side. That means I need to get rid of the positive 8q. The opposite of a positive 8q is negative 8q or subtract 8q. Let's do that. So we have 7q minus 20 equals 15. Awesome, we have 7q over there, but we don't want the minus or subtract 20. So I'm going to add 20 to both sides. 7q equals 35. We want q. The opposite of multiplying is dividing. We divide by whatever is hooked to the variable, which is 7. So we get q equals 5. Let's check it though. What we do next is we put 5 in for our variable. On the left side of the equal sign, we need to do what's in parentheses first. So 3 times 5 is 15. On the right side of the equal sign, 8 times 5 is 40. 15 minus 4 is 11. 40 plus 15 is 55. 5 times 11, woohoo, we did it, is 55. So yeah, q equals 5. Now look back at your work. Was there anything that you were confused about or you didn't get correct? That's what you need to practice. Now, what are your video tasks? You need to practice, okay? Practice, practice, practice. So if you're watching this for a class, you need to do the homework. It's really important. Even if your instructor says the homework doesn't count for your grade, you still have to do it, okay? Practice, practice, practice. Did you like the video? Well, then like it. Did you really like it? Well, then come on and subscribe. Finally, did it help you? Well, why don't you share it with your friends? Remember, it's not magic, it's math.